Welcome to next-gen manufacturing. You know, in the world of high-tech production, where every single micron matters, precision isn't just some buzzword. It's everything. We're building incredible things, right? From jet engines to surgical implants, and it all boils down to how perfectly each tiny part fits together. But what happens when that perfection is threatened?
So let's really think about this for a second. When you picture a huge manufacturing failure, you're probably thinking of a machine breaking down spectacularly, or maybe a massive flaw in the design. But what if I told you the most common, and honestly, the most costly threat is way, way smaller?
Yep, that's it. A single hole drilled just a tiny bit off-center. It sounds so trivial, doesn't it? But this one little mistake can literally bring an entire production line to a grinding halt. So today, we're going to break down exactly why this happens and go through 3 essential tips to make sure every hole you drill is perfect every single time.
So how bad can one misaligned hole really be? Well, the consequences have this nasty ripple effect, and it touches everything from the assembly process right down to the bottom line. It's a textbook example of a tiny mistake causing a monster headache.
And you can see just how fast things can spiral out of control here. If a hole is off, the part that's supposed to connect to it, well, it just won't fit. Simple as that. That means the assembly is a failure, and at precision manufacturing, you can't just grab a bigger hammer and make it work. Here's the kicker. This almost always means the entire component has to be thrown in the scrap bin. That is a total waste of expensive material, precious machine time, and of course, a whole lot of money.
All right, if we're going to beat this problem, we've got to understand it first. A misaligned hole usually shows up in one of 2 ways. Figuring out the difference between them is the first step to stopping them from ever happening in the first place.
So on one hand, you've got angular misalignment. Just picture this. The holes are drilled at a slight tilt, so their center lines are never going to meet up properly. A pin or a shaft trying to go through both? Nope, it's going to get stuck immediately. Then you've got offset misalignment. Now with this one, the holes are perfectly parallel, but one of them is just shifted. It's in the wrong spot. The angle is right, but the location is wrong. And you know what? Both of these problems lead to the exact same frustrating result, a failed part.
Okay, so how do we fight back? Tip number 1 is all about setting yourself up for success from the very first moment the tool touches the metal. It's a really simple, fundamental technique that makes a massive difference.
I want you to meet this spotting drill. This tool has one job, and one job only, to create a perfect tiny little dimple right on your target. This little cone-shaped mark acts like a guide, and it keeps the main drill bit from wobbling or walking off-center when it starts cutting. Think of it like a pilot car, clearing the way for your drill.
Now, I know what some of you might be thinking, but that's an extra tool change. That adds time. And yeah, you're right, it does. But just look at the payoff. You're investing a few extra seconds to guarantee perfect hole alignment. That means you completely avoid the risk of scrapping a part that you might have already spent minutes or maybe even hours working on. When you look at it that way, it's an absolute no-brainer.
And this quote just nails it, doesn't it? It says it all. That little bit of time you invest up front is basically insurance against a much bigger, much more expensive failure later. It's all about working smarter, not just faster.
All right, let's move on to our second tip. Now, we're going to zoom in and take a closer look at the drill bit itself, because there's this feature right at its heart that creates a really interesting engineering puzzle. We're talking about the web thickness. This is the solid spine running down the center of the drill bit. It's the very first part of the tool that actually makes contact with the material, and it's what gives the drill its strength and rigidity. So, common sense would tell you a thicker, stronger web is always a good thing, right? I mean, more strength means more stability, but here's where things get a little weird. Why on earth would a stronger drill actually be a problem for accuracy?
And there it is. That's the catch. That big, thick, strong web has a larger, flatter point right at the very tip. And that makes it way more likely to wander or walk around before it actually starts to cut into the material. So the very thing that makes the drill strong also makes it less accurate right at the start. So how do you get the best of both worlds? Strength and accuracy. Well, the solution is this really elegant bit of tool design called web thinning, or what's often called a split point. The manufacturer actually grinds away a little piece of that web right at the tip of the drill.
And this tiny modification is a total game changer. It creates a much sharper, more precise point that just doesn't want to walk. It also means you need way less force to push the drill into the material. So you get a cleaner, more accurate start to your hole,
all while keeping the strength of that thick web through the rest of the drill's body. It's brilliant.
Okay, our final tip today is probably the most straightforward one, but honestly, it's the one that's so easy to forget about when you're in a rush, and it's all about making sure you've got the right tool for the job.
It sounds almost too simple, but it is so important. Don't just grab a general-purpose drill when there's a specialized one that could do the job better. Drilling into hardened steel is a totally different ballgame than drilling into soft aluminum, and your choice of drill bit needs to reflect that.
You see, these material-specific drills are engineered from the ground up to deal with the unique personality of a certain material. The cutting angles, the design of the flutes that pull the chips out, the high-tech coatings, they're all optimized to cut cleanly and efficiently in that material. This lowers the cutting forces, stops the drill from walking, and at the end of the day, gives you a much better, much more accurate hole with a lot less effort.
So let's recap. We've talked about spotting drills, web thinning, and using material-specific tools. 3 pretty simple tips to fix one seemingly small problem. But when you zoom out and look at the big picture, you start to realize this isn't the small problem at all.
Think about it. Every complex machine we rely on, from the smartphone in your hand to the rockets launching into orbit, is just an assembly of precisely made parts. And what holds all of those parts together? Perfectly aligned holes for bolts, for shafts, for pins. They are the quiet, unsung heroes of modern engineering.
The quest for that one single perfect hole, repeated millions of times with absolute consistency, that is what makes innovation possible. It's what lets us build the incredible, life-changing technologies that define our world. So the next time you see a jet fly overhead, just think about the thousands of simple, perfect holes that are holding it all together. Makes you wonder, what are we going to build next?